guys, my name is Pavel Krupola from blenderfreak.com and welcome to the part number 9 of the Node Editor tutorial series. And in this part our final result will be edges which actually can calculate correctly where they start and where they end, like this. But this part is going to be a little bit different because every time you start writing a code, sooner or later you will get stuck because it's gonna be broken and you can't avoid it. It's just the way it is. Everybody makes mistakes, even you will make some mistakes. So I want to show you my way of debugging the code, and I have to say that this is not the only way how to debug the code. You can use, for example, debugger here and test a lot of things with this stuff. But my personal way how to test and debug the code is by writing stuff into the console, which is here. At a first look you can see it can be messy, really messy. But once you get used to what you are actually writing out, and I mean like what these numbers mean, what these references mean and stuff like this, then you are actually testing the code every single time you run it. So you are deciding what you are going to write out, so you know what the values which are written out are supposed to be. And because you run it usually more than once, you can easily increase your chance to find a mistake you made in your code and fix it. For example, the first number here is the index of the socket and the second one is the position. So I definitely know that I have been using 3 input sockets, 1 output socket, so this number should be 0, 1 or 2 and nothing else. So if I don't see these numbers in this order, I know there is something wrong with setting up the socket. So I hope you will learn something, and let's start with coding. So last time we ended up here. We are having 2 types of edges which are actually not connected to the sockets yet. But instead of referencing the sockets where to start and where to end, we are using the position source and position destination. So we can go ahead and basically define some setter functions for the source and for the position. So we can say define set source and pass x and y parameters and say self pos source equals to x and y, and the same thing we are going to do for the destination. So define set destination self x and y, and we are going to call self dot post destination equals to x and y, like this. Okay. When we go to the edge, we do have start socket and end socket, but we don't have any reference to the edge in the socket. So we can go ahead here and say self edge equals by default to none. So therefore we can actually control or check out if this current socket has an edge connected to it or not. Then when we go to edge, probably we need to remove it from the socket itself. So we can define a new function for that and say remove from sockets. And this function will be basically called when we are going to, for example, delete the edge. So we can check out if it's actually connected to some socket or not. So it's better to be safe than sorry, because self end socket and start socket can be none. So in that case we are going to do a check for that. So if self start socket is not none or is not empty, then we can go ahead and call the start socket then access the edge and say the edge will be none. The same goes for the end socket, so self end socket is not none. Then we are going to say self dot end socket dot edge equals to none, so clear the edge from the socket, and then we can say that the self end socket will be none and self start socket will be none too. Same way we can actually call or create a new method called remove. So this method will first go through self and remove from sockets, so we can delete any references to sockets and edges to itself. The next thing we are going to do, we can go to the scene, graphical scene, and then we can call remove item, and we can delete self gr edge, so remove the graphical edge from the actual node editor. For being sure, we can delete the reference to the QDM graphic edge, whatever thing we are going to have here. So we can go ahead and say self gr edge will equal to none. And the last thing, we do have in scene lists which contain all edges, so we can go ahead and say scene remove edge and call it with this edge. So this should be everything we should do to properly remove all the connection to the nodes and edges and sockets itself. But we will not test it out yet, because the delete functionality we will do it in some later chapter. So let's go ahead and check out the socket. So here in the socket we got self edge equals to none. So it would be probably good thing to have some method to set the connected edge and call it with self edge. By default we can say connect it to none, so we can call it without parameter, and this will reset the socket itself. So self edge equals to edge, like this. This is pretty simple. And for the rendering stuff, we are basically gonna need to have some kind of a method which will get our socket position, and this will return X and Y position of the socket. So the way we are going to know what the socket position actually is, we basically already implemented that in our node, I believe. It was somewhere here. Here is a function get socket position, which takes actually index and position. Okay, so index and position is set up here in the socket, so we can go ahead and call self dot node get socket position, and we are going to pass index, which is self dot index, and we are going to pass position, so self position. What can we do next is we can go up to the edge again, and let's have a look. We got an edge, we got a starting socket, end socket, graphical edge, add to the scene, remove from socket, remove itself. And for the edge we can define a new function which we call update positions. And here we can basically implement the logic of setting up the position of the edge itself. So we can go ahead and say self gr edge set source, and we are going to need to pass x and y parameters. So we can go we can call self start socket dot get socket position, and let me check it out. We are going to call this get socket position, and this should return node get socket position, which is defined in our node, and this one is returning x and y as a couple of parameters. So therefore we do need to call it with a star, and then we can just say that if the self dot end socket is not none, we are going to say that the self grh set destination will equal to self dot end socket dot get socket position, like this. After we are going to set up the start position and the end position, then we can call self grh dot update, like this. If you are wondering why we are checking the end socket for not being none, and we are not checking the source for not being none, the reason for that is quite simple. Because if you imagine when we are actually creating an edge, we will definitely create it in our window somewhere like this. So in this case we already know that the edge definitely connects one socket and another socket. So in this case we are going to know exactly what the source and what the destination will be. But there is one special case when we start clicking. Let me show you. If we start clicking here, then we want to see an edge being dragged around, and in this case we don't know the end socket yet, so therefore the end socket can be empty. But definitely we know that the source socket where we started in will already be defined itself. So in our case there is no option that the source or the starting socket will not be set, so therefore we don't need to actually check it out if it's not none. And then what we can do is just go up here to the constructor, and before we add the edge to the graphical scene, we can actually call self update positions, like this. And now when I do run, it will disappear and our edges are completely lost. And why is that? We can do update positions, and let's do some debugging so you can see how do I actually fix this in a real time. So after we define the positions, we can go ahead and update them, and let's do some test debug and write out the actual positions of the graphical edge. So this was pos source, and it was going to self.grh pos destination. Let's check it out. And as you can see, our edge is going from 0.38 to 0.38. So that means that our sockets are returning probably the wrong position itself. So here is the start socket and here is the end socket. So here we can probably do some next debugging, and we can print out what actually are the instances of the start socket. And this will be self start socket, like this, and then we can print out end socket. And let's move it a little bit with a space and call self and socket. So let's have a run. Here we can see that the starting socket is an object with this number and this number. All of them are different, which is okay, that works. Okay, so that means one thing, that maybe the end socket and start socket are not returning the correct position itself. So let's go ahead to the socket position, and this one just passes out the index and position. So let's check if this is actually correct. So print out get socket position, and we are asking for self index and self position. When I press play, then you can see that we are actually asking all the time from the index 0 and position 1, and the same thing for the another edge, which is not actually correct. A result. So let's print out the result for that, like this. And here we are returning a result. And the result here is 038, 038. So these things are passed correctly. What we can check out next is the node, and we can pass this in, and the node is this object, and this one differs from this one, and so that means that the nodes are actually properly passed to, but the index and the position is not. And one reason for that can be probably when we are creating a node, which was, I believe, here, node. We were creating these kind of things, and we were passing index and position here. So that means that when we are creating or instantiating the socket, somehow the index and position are the same, which doesn't make too much sense. So let's try to do some debugging here, and let's say socket creating with self.index at self.position for node self.node. Okay, we can go ahead, and we can see that actually index and position is being passed correctly for the nodes. This one has 4, 0, 1, 2 and 0, and they are on position left top, which is 1, which basically this one should be different, I believe. So this is position, and as you can see, here needs to be passed the position. And I probably guess that all of you have seen this bug the whole time I was trying to find out where it is. So now when I press play, you can see we got edge from one point to some other point. Okay, so this bug is fixed, and the edge is starting from 138 to 0226. So they are basically starting from the same place. which is not correct. So that means if we go up to the node, to our function, which is called getSocketPosition, we are going to count the positions actually correctly. But in the case we are asking for this position here in the edge, graphic edge, node edge, here, update positions, we do need to add the node's position itself in the scene. So we won't write it like this, and we can type source position equals to this thing and pass source position here. Same is going to be here, end position, and let's say end position will be this thing. Oh, basically we do need to keep the star here because we are passing it through an array. What's the position of the current socket node? So that means we are going to add self.start socket.node, and then we can ask the graphical node about its position and ask for the x and for the y. Plus equals. So let's test it out. Okay, it doesn't work because get socket position from the socket here is actually returning node get socket position, which is up here, and this is interpreted as a tuple. So let's make it a list like this, and now you can see that it leads from actually basically correct x position to some y position. So let's check it again. It goes from one point to another. The same thing, it starts correctly here, and the end position is again not fixed, but the starting position of x is correct, and for y is 2 already. So let's go ahead and check it out. We were actually changing the node edge, which is here. So here we can go ahead and basically copy paste these two lines and say that it's gonna be end position, and we are going to ask the end socket node position x and position y. So now when I press play, you can see that the nodes are connecting and ending in the correct sockets like this, which is actually cool. So let's try to change this one to be connected to the for example the middle socket or the last one. So this should be 0, 1 and 2. Should be pretty simple, and we can go to editor window here, and this one was, I believe, here. So the end socket will be node 3 input second, and as you can see, these are connected correctly. So the last thing at the end, I went through the code, and wherever I print something out to the console, like here for example, I added if debug statement, so I can have one debug constant here in the file, so I can control which of the debug code will be visible and which one will not be visible. For example, I don't need the socket debugging here, so I can simply turn it off by typing debug equals false. That's gonna be it for this part, and see you at the next part.